Right, good evening. Long time, but thank you very much for joining us. This is going to be one of our very last classes that we do, where we talk of natural deductions, right? So I think everything else leading to natural deductions has been discussed, modal logic. Then I know there were requests for us to do a short video explaining models again. So that is still in this pipeline. I'm going to do it. So we just want to see how we're going to structure it and put it on the portal, right? But today we're going to be finishing off, and we're going to be looking at natural deduction for modal logic. Right. So all this build-up we've been having or been doing has been about two operators that we have. These two operators have now been left up to be defined as box and diamond in a broader sense, but more or deeper, we have been defining them as necessarily and possibly. Right. But now when we talk of natural deduction rules, we saw that from the previous class, we now start hearing mention of knowledge, agent knowing. Right. So when you look at this is now bridging a very close gap between logic and artificial intelligence. When we look at artificial intelligence, we are all talking about agents, and agents knowing. The knowledge of agents is based on their precepts and whatever knowledge that they have before. So that is the base of it all. So when we talk of natural deduction rules, especially in terms of modal logic, we are talking of knowledge of the agent, right? So we say that when we start looking at this, we say if agent knows phi to be true, then phi is true, right? Then we say if agent knows that they know phi is true, then agent knows that phi is true, right? So these are some of the things that we came across, right, where we said are valid arguments. So as such, you're going to add two new rules to natural deductions, right? So we're going to have box introduction and box elimination, right? And please take note, any question that you're going to see that will ask you, right, about diamond, anything that is diamond, you are allowed and you have to convert it to box negation box, because we said diamond is equivalent to negation box negation. So the natural deduction rules are coming back again. So if you had not revised on natural deduction rules, if you don't know what I'm talking about, now is the time for you to go and start looking at them. So we saw 10 marks under question 1, 10 marks under question 2, and 10 marks as well that you see under question 3. So that's about 30% that will be calling for natural deduction. Right. Now, if we want to do box introduction, right, we cannot do box introduction intro before box elimination, right? So hold yourselves whenever you are dealing with natural deduction rules for modal logic, right? Why? The introduction of this box, as you can see, only comes when we are eliminating a box, or this checked box, checked assumption box. It only arises when we eliminate a box. So box introduction will only happen after we've done box elimination, right? So it says if you have used box elimination somewhere and at the end you're able to prove phi, then we can conclude that box phi is true, and we call that box introduction, right? But if you are given box something, right, it's true, or it's confirmation that agent knows something, then something is true. So we are deriving it from this. Then we are in the scope of the agent, we are saying that this is true. So this represents the scope of the agent, right? So this is box elimination. You remove the box under the checked, sort of, let me call it a checked assumption line. Right. So these are the two rules for natural deduction rules, which is box elimination and box introduction. If you do not want to use box introduction, or the situation does not call for you to use box introduction, there's rule T, there's rule 4, and there's rule 5. Right. So rule 4 says if the agent knows, then they know that they know. Right. If the agent does not know, then they know that they do not know. Right. If the agent knows something to be true, then it is true, which is T. So box eliminate introduction, box elimination, T, 4, and 5. So this is the K rule. So we've got K, T, 4, 5. These are the natural deduction rules that we have. Right, now let's try and use them. So we're given this. So this is from a previous assignment, right? But this is how you go around with the assignment questions as well. Right, question 13 says, how many times are box elimination and box introduction rules used in the above proof? Right, so we see that box elimination, we only see one checked box. So box elimination is used once. So in fact, this was an assumption. And then this is box elimination, right, on of 1. And then this is end elimination of 2. And this is end elimination on 2. Then this is now box introduction, and this is box introduction. So we see, or we say that we have got box elimination once and box introduction twice. So box elimination is used only once, but box introduction twice. So this is the correct option. Why? We can only notice box elimination once we have observed an assumption, checked assumption box. So it is possible for you to say box elimination, say we've got box P, to say box P is as a result of box elimination in the same subproof. It is possible in the same checked line. Right. So that is how we would go about with that. Right. Is there anyone who is not understanding? Now, let's go to the next one. We are given this, and they say what is the correct reason for step 1, 2, 3, and 1, 2, and 3 for the above proof. So 1, we said it's an assumption. 2, we said it's box elimination. 3, we said it's conjunction elimination. Right. So 1 is assumption. Anything that's saying premise is wrong. 2 is box elimination. 3 is conjunction elimination. So this is true. Option 4 is. What sequence is proved by the above proof? What sequence is proved by the above proof? What are we trying to prove? So we have got box P and Q implies that, because from no premise we've managed to prove that. So we are trying to prove that this is true from no premise. So because that is the only assumption that we made. We see this, it says rules T4 and 5 are used in missing lines of the above proof. Which rule is used in which line? So the missing lines are, so which rule is used where? So we've got an assumption here, right, in this, and then so in line 2, 4, and 5. Where is 5? But 5 is given missing line and 7, 2, 4 and 7, right? So if you want to prove this implies that, then the last element in your this should be box P. So we said from the rules we have got T is given by box phi results in phi. Then 4 we said it's box phi results in box phi. So we said confirmation of knowledge. Then 5 we said it's contrapositive of confirmation of knowledge. If you do not know, then you know that you do not know that. So these are the 3 rules. So here we say we are using rule number 4. Over here, inside, we need something that would make this or result in a contradiction between number 2 and number 4. A contradiction in number 2 and number 4. So whatever is here and there leads to this contradiction. So if we have got negation of box P, right, if it means that box negation box P is true. And this is a result of rule 5 or axiom 5. Right. So it means you are supposed to have negation of box negation box P. Right. So this is number 5, and then this we see to be T because we are eliminating this box and we are remaining with everything else. So number 2 we are using rule T. Number 4 we are using axiom 5. Number 7 we are using axiom 4. So rule T is used for number 2. Rule 4 is used for line 4, wrong. Rule T is used for line 2. Rule 5 is used for line 4. Rule 4 is used for line 7. So this is the correct. What formulas belong to the missing? So if you look at the same one, which formulas belong here? So here we said it's negation box P. Here we said it's box negation box P. And then here we say we said this was going to be box P. So we look at that. Anything that does not start with a negation is wrong. Then negation box negation P in line 2, correct. Then negation box, this is wrong. So this one and this one is correct. So option 1 would be the correct solution. Let's now look at these questions. So they say, what proof strategy would you use to prove this? What proof strategy would you use to prove this? So here I'm saying, so they say use KT4. So these are the applicable rules that you can use KT and 4. We are proving an implication. And we said if we are proving an implication, right, we start by making an assumption. Right? And the assumption would say, open an assumption box number 1. We assume the left of the implication. From this, we want to prove this over here, right? So we can say, well, we can have box P and Q. We are using the rule T on number 1. Then from here, we can then have so this looks similar to something that we did before, right? The one that we did multiple choice. We can say P and Q, and we say that this is box elimination on number 2. And then number 4, we've got P. This is conjunction elimination on number 3. Number 5, we've got Q, conjunction elimination on number 3. So this is 1, this is 2. Then from here, we then say number 6, we can prove box P. This is box, number 6, we can prove box P. This is box introduction on number 4. Number 7, we can prove box Q. This is box introduction on number 5. Right. Then number 8, we're going to have box P and box Q. And this is conjunction introduction on number 6 and 7. And then since we have proved this, we can close this assumption box. And then what is the conclusion? Our conclusion then becomes box P and Q implies box P and box Q, and this is implication introduction from number 1 to number 8. This is how we would go about with this. So next we look at that. Says if we interpret, so this is multimodal logic. Right. If we were to interpret K, I being a subscript as agent I knows phi, what is the English translation of K1, K2, that? So we've got not Q implies, not P implies Q, not P implies Q. So what you see here is the agents are only attached to P, or rather to not P. So let's go about it. We say, if we interpret Ki as agent I knows phi, what is the English translation to K1, K2 knowing? So this says agent 1 knows, right? Agent 1 knows that agent 2 knows not P, right? So in the whole context, we are saying if agent 1 knows that agent 2 knows not P, then Q is true. If agent 1 knows that agent 2 doesn't know P, wrong. So there's a difference between agent knowing not P and agent not knowing P. This is agent not knowing. This is agent knowing not P. What is the difference, one can ask, between an agent knowing and agent not knowing? So if you know not P, it means you know the negation of P. If you do not know P, it means you have no knowledge of P. There is absence of knowledge. Not knowing refers to absence of knowledge, whereas here we are demonstrating presence of knowledge of what P is not. Right. So here it is absence of knowledge, but here we've got presence of knowledge. So here we've got if agent. So our statement is supposed to begin with if because we've got an implication there. If the agent 1 knows that agent 2 knows not P, then Q. So this is the looking at some more. If we interpret agent 1 knows, what formula of modal logic is correctly translated to? Agent 1, K1, knows P, but, which is end, he does not know, agent 1 does not know that agent 2 knows Q, like that. So this is the interpretation. So let's look for it. Agent 1 knows P and agent does not know that agent 2 knows. Another one, interpretation of multimodal logic. If we interpret as that if agent 1 knows P, agent 1 knows P, then agent 2 does not know Q. Agent 2 does not know, so we've got none of these 4 or 5 look as if it's the correct option. So this is wrong because agent 2 knows not Q. Here they are expressing presence of knowledge. Now let's go to our bag of tricks. We know that P implies Q is equivalent to not Q or P. So we're going to have it's not Q or P, right? It's not Q or P. So we're going to have not Q or P. So Q is going to be K2Q or P, which is K1P. right? So this will be the negation of knowledge here. So agent 2 would know Q, or agent 1 would know P. So do we have something like that? Not K1P, not K1Q. Right, so let me just confirm. P implies Q means, is it not P or Q? Let me just confirm this from a truth table. P, Q, true, true, false, false, true, false, true, false. So not P or Q is, here is true, not P, false, or Q, false. Then we've got not P, true, or true is true, true. Yes, so this is supposed to be not P or Q. Apologies for that. It's supposed to be not P or Q. So not P or Q is going to be not K1P or not K2Q. Right. So this is wrong as well, right? Because it is not what we have. Let's look at option 2. So if we put the negation in, it is going to flip the sign to an O and distribute the negation across. So the correct answer is going to be option 2. Let's look at agent 1 knowing something. So the agent knows that agent 2 does not know P. Right? Agent 1 knows that agent 2 doesn't know P. I think we've done this before. Agent 1, if agent 1 knows that agent 2 does not know P, then Q. So if agent 1 knows that agent 2 does not know P, then Q. Right. So that is, in a nutshell, natural deductions in terms of modal logic. So the only additions were the two where we talk of where we are talking of how can I put it? When we are talking of box introduction and box elimination, and we said box elimination comes first before we have box introduction, right? So in the interest of all fairness, I'm going to ask us to do a few more questions, especially on the practicality of doing how can I put it, of doing of doing the actual deductions as they will come in the exam. Let's look at two more. So it's going to be worth 9 marks, and they ask us to say prove the following sequence is valid. So we are given, number 1, a premise not P implies Q. Okay, and we want to prove that this implies that. We said if we want to prove that, we do an assumption. We assume not P, not box, not P is an assumption. Then number 3, we are going to say we want to prove this guy. We would like to prove this guy. Right. So the only way to prove this guy, or a way to prove this guy, might be to use proof by contradiction. Right. So what would I do if I want to use proof by contradiction? I would assume its negation. So I would say box not Q is an assumption. Then if I've got box not Q, if I were to do box elimination, number 4, I do box elimination, and I have not Q is box elimination on number 3. I can also come here with number 5 with P implies Q is box elimination on number 1. Yeah, so box elimination, because we've opened, we've done a dotted subproof. Once we have here, we can number 6 have not P to be true, and we call this modus tollens on number 5 and number 4. Once we have that, okay, we can close this one off. Then number 7 is going to be box not P, and this will be box introduction on number 4 to 6. Right? Then once we have this, we are going to have box not P, and we are going to have negation of box not P. Then we are going to have number 8, a contradiction now between negation, elimination between number 1 and number 7, 1 and 7, right? And then once we do that, number 9 becomes, from here we now prove negation of box, negation Q, and this is negation introduction on number 3 to 8, or we can call this proof by introduction, proof by contradiction, proof by contradiction between number 3 to number 8. And then once we do that, we can then say, sorry, this is not an assumption. We can then close this one off, and we conclude number 10 that negation of box, negation of P implies negation of box, negation of Q. And this is implication introduction on number 2 to number 9. So that is it for this one. Any questions? So we've done this one. Let me stop and say, leave this as homework, but we have done this as it was given, to say P and Q implies box P and box Q. We have done this one to prove this, only that now we do not have to start by assuming. We start with this as a premise, right? So that should be an easy one to go through, and we have also done it earlier when we were looking at the homework question. Right, so that's it. If you come across more questions, again, feel free to come back through. Otherwise, we should have enough to practice with, and also look out for the you receive a notification regarding the models when it's available, so that you can also look at that, right? Especially models with 2 variables. So this speaks to assignment 2. Right. So enjoy the rest of your evening, and we'll see each other again. Possibly we are going to schedule a session to look at assignment 2, right? We're possibly going to do that. So just keep an eye on the timetable. You also receive emails pertaining to that. So thank you very much for joining. Enjoy the rest of your evening, and good night.